Welcome to the Probability Podcast. Discussions on emerging and converging technologies, problems that are being solved, and the probability of positive and negative outcomes that we might expect. Now, please welcome your hosts, Jason, the generator Spracklin, and Patrick, the discriminator Lozon.
Hey everyone, and welcome to the Probability Podcast.
This episode is part of a special trilogy on the next great exploratory horizon of our planet, the ocean. We are entering a pivotal era where the abyss is becoming a space for expansion of high-tech, autonomous navigation, sub-ocean habitats, and high-stakes deep-sea mining. Across these 3 episodes, we'll examine how we are mapping the unknown, learning to live at extreme pressures, and navigating the massive economic and environmental risks.
This episode marks the final chapter of our trilogy on the ocean, where we will explore the high-stakes, highly automated world of deep-sea mining. We'll dig into the $20 trillion economic opportunity hidden in potato-sized polymetallic nodules and cobalt-rich crusts. These are the critical materials required for electric vehicle batteries and a low-carbon future. To reach these resources, we'll have to break down the high-tech robotics making extraction possible, from AI-navigated underwater vehicles to massive riser systems engineered to lift ore from the depths. However, this industrial gold rush risks irreversible ecosystem collapse and massive sediment plumes that could disrupt global food webs. We'll discuss how permanent deep-sea habitats could serve as a vital circuit breaker, providing real-time monitoring and regulation needed to ensure this race for resources doesn't destroy the planet's most mysterious frontier. So join us as we discover whether deep-sea mining is the key to a green revolution or a tragedy waiting to happen. So Patrick, have you ever spent time with miners? My advice, tell the truth. These men work in the dark. They see everything.
Well, let's talk about working in the dark, many, many miles down in the ocean. It's a scary place.
Is it more scary than deep space, or is it, equally as terrifying?
It's, I would say, more terrifying. Because, I think a vacuum is easier to manage than, having 10 tons of pressure squeezing your little, submersible down to the size of a die.
Well, you're in an area where no light penetrates, right? At least, I guess, in the deep sea, you can kind of navigate, but you're relying on other technologies, right? Where you don't have the kind of light you have, at least in the universe. At least you have the sun in the universe where the planet's generating some kind of light. You're not in just pure blackness, as it were, right?
Yeah, what do they call it? The abyssal plane? The abyssal plane. You want to hang around? Let's go to the abyssal planes. I don't want to go there. Sorry.
Well, that's where the movie The Abyss came from, I would imagine, right? Like a lot of these deep sea type movies, they always play off of that kind of theme, right? Like The Abyss or what have you, right? About something that seems very terrifying. In fact, I guess that was a trend, I guess especially in the 80s, maybe to the 90s. They did a lot of movies about, a lot of horror movies about the deep sea, about vessels going down and getting attacked by a giant monster or something, equally, terrifying but strange. There was a number of movies along that theme that kind of emerged as a series in the 80s, I think it was. But
we don't know what's down there. We don't. We know there's polymetallic nodules, but we haven't. Like I said, we've only done 27% of the ocean mapped. Most of that is around critical areas where, we're mapping, which we are actively investigating, like the seafloor around the Antarctica, and of course around critical areas for navigation and around the continent, right? But it's the continents, I should say. But when we start looking into the, deeper parts of the ocean, which aren't traversed at all, right? What's the point? Why do you want to spend the effort? I mean, there's areas like we talked about, was it Point Nemo, out in the middle of nowhere? I mean, who really cares, right?
Yeah, no, exactly.
Yeah. So I think that's part of the challenge too. Is you're going to spend have automated uh, you know automated equipment running around and slowly build up this data mountain of data around what is actually down there. But the idea of creating them, like a Google Earth and a Google Ocean, so to speak, where you can actually see the depths and be within a few meters accuracy on that. That's great. I mean, if you're a submariner, but that's not going to really change things too much when it comes to who is actually going to be, going down there. Really.
Well, yeah, but I mean, the economics are driving, the bulk of it, right? I mean, that's the case for so much of what we talk about, right? But certainly in this case, what are they going after? They're going after certain types of, minerals and, as far as, valuable metals used in batteries, electronics, that type of thing. So, I mean, it's not that those things aren't available elsewhere. Maybe they have, specific properties if they, are in the ocean exposed to certain things. But at the end of the day, it's definitely about the economic. They wouldn't go through all the trouble if it wasn't for the economics of what they're going to get from it, right? And that there's a lot of it is unexplored. So there seems to be a lot of, quote unquote, like riches just waiting, right? And it's, as we kind of talked in the opening, it's a lot of them are critical minerals for modern technology. And we don't often think about, all the things that fuel everything we do every day, right? Whether it's the laptop I'm on right now, my phone, whatever it is, your car, right? They all require, to some degree, some sort of rechargeable battery, renewable type tech. You have your consumer electronics and the things that are needed there. And these things don't exist without all these minerals. And of course, every year, everything gets phased out, gets depreciated or purposely kind of like downgrade it in the sense that you have to go and now buy the latest upgrade, right? Every year people are buying more and more new phones and new devices and new everything, and it's not all just being manifested out of thin air, obviously, right? And a lot of it's being driven from these minerals they need, and that's, I guess, what drove us into the sea to start looking for them, I guess, right? Because there's obviously like an abundance there, right?
Well, what's funny too, when we talk about what's at the bottom, the very depths of these, 6,000 meters down, what are they finding, right, on the floor of the ocean, on these plains? And they found these nodules, and these nodules have been, it's like a grain of a shark tooth, or a grain of sand or something, and what it happens is over time is it's like an accumulation or aggregation process where these nodules slowly collect and pull the minerals out of the ocean water, and they combine onto this little ball, right? And you get this, iron or manganese or, cobalt or nickel or copper all collecting this one kind of ball. And if you watch in any kind of, there's some interesting deep sea footage, and you look across this plane of the ocean, and of course you can only look as far as you can see with lights, of the deep sea drone, and because it's completely dark down there. But look at as far as you can see, and there's these little balls on the bottom of the ocean floor, and so that's what they want to go get, right? Now, I know there's lots of conversations around, well, what's living down there. You're going to disrupt their patterns, right? you're going to disrupt that life. And that's true. If you go down there with a big old vacuum or some kind of track thing or screw mechanism or what have you to pull up these nodules, and you manage to, we'll get into the details of what's involved to get all that up to the top of the ship, up 6,000 or 4,000 meters up. There's a lot, by the way, a lot of engineering to make that happen.
Oh, I bet, yeah.
Yeah. So, but down there, right, it's 16,000 PSI, right? You don't even have vessels, that can maintain one atmosphere over, the course of, a number of years to be reliable, right? So the idea that this really is it's a zone for robots, right? It's a zone for the drone activities. It's not a zone for mankind, right?
Well, it just wouldn't be a podcast if we didn't somehow bring AI into it, right? I mean, and robotics and everything else. But I mean, there is a case for doing it more safely. I think that's the direction we're going, right? But I mean, we talked about off the top as well, this idea of like a $20 trillion industry, right?
Possibly, yeah.
There's an opportunity, like an industry analysis suggested that, the global economic opportunity from seabed mining can reach 20 trillion over time. Mining a portion of the seabed might yield, 20 to 40 billion in gross metal value over 20 years. So, this is all sort of speculation to a point, right?
Yeah.
But it does say that there's a potentially higher concentration of metals. You try when you're mining on land, for example, like you talked about disturbing, things in the sea, but certainly when you're doing it on land, you're impacting, the earth, like deforestation, right? Tailing ponds that come from a lot of these mining activities, which are highly contaminated, freshwater pollution. It's sort of like if you're doing it on the land, there's a lot of consequences as well. So I guess the idea is that, well, not that the ocean's not important, but certainly they're avoiding some of those land mining impacts, for example, right? I think it's like you described, right? Fewer risks in terms of automation and, robotics and all that kind of stuff. And I think it's an interesting dichotomy of, no matter where you do it, you're still causing a disturbance to the natural environment. But that's the world we live in right now, right? Nobody wants to live without their phone or their car or what have you, right?
Yeah. And the idea that where we're going to get these, metals, these minerals, once we kind of find all our sources, right? And true enough, we may not, we're probably a long ways away from finding on every country the mining resources that we have today for these minerals. But at the same time, we got to balance that out with damage to our environment, right? If you're going 6,000 meters down in the ocean, what are we interfering with there versus, a few hundred feet above sea level where you're mining and you're producing all this, waste that is part of the refinement process and mining process that is very difficult to deal with. All this pollution, you're obviously destroying the environment on our surface. It's not a, mining is, first off, it's very dangerous, and it's incredibly risky. It's
oh, of course, yeah.
Right. It's from a point of view of, can you, get rich mining? Of course, you can make incredible amounts of money mining, but that's still there's luck of the draw when it comes to, finding that, magic vein of minerals, right? Geology has gone a long way in the science of understanding you know, where these, particular pockets are of these
And what
resources.
lives there, right? We don't know, essentially, right? It was saying that some surveys find 90% of species, and there are these nodule fields, may be new to science, basically implying an incomplete understanding of ecosystems before mining is even attempted. So, in other words, like, we're going to go down there and mine because we've found this field of nodules. I guess that's but essentially, we're going down and disturbing things that we don't understand either. And what's the
Well, yeah,
implication of that to the overall ecosystem of the ocean? And so much of this world depends upon the ocean, the health of the ocean, and the temperature of the ocean, and the toxicity of the ocean. That is, it's not to be messed with in some ways. I mean, to an extent, right? I mean, obviously we do a lot of different things in the ocean, but it's an important part of the entire ecosystem we live in, right?
well, I understand that, right? It's, well, I mean, what we're really talking about is a very small percentage of the ocean that's going to be affected. Um, over time, even, if you look at the vastness of the ocean, um, the current plans, there's this Clarion Clipperton zone they're looking at on the Pacific. Um, it's kind of like in the middle of the Pacific. That zone, as far as they're concerned, is completely free of any, you know, known uh, uh, interf- or significant biological, uh, you know, type of life. So by when they actually do the work, it's like anything. You don't know till you go down there. You start doing things, and then you find, then you discover. Right, right now there's no need, no desire to actually go down there to find out. Right, so we have to do what we have to do. I mean, this is all part of our. I would prefer that they, that we would mine on an area which is not really affecting any kind of life. That means that down in the ocean floor where there's a higher percentage of it not affecting anything versus on the surface, right? Where you're displacing whole towns and possibly wildlife, the whole thing, right? Is much more difficult on
What
the
you don't?
surface side.
You're saying you don't really care about Flipper? Then you don't care about Flipper's habitat?
Flipper don't swim that deep, but we could. What are the real risks, right? I don't think we really understand the real risks because we don't know, right? But that's the whole point. And the point is, you you gotta go through the discovery and figure that out. Um, could you break up the Kraken? Could you wake up some Godzilla? You know, I, I I I think a lot of that is science fiction, best left science fiction. I love science fiction. You
Well,
know,
yeah. I mean, to a point, though. But I mean, we're all already discovering a lot of odd species in the deep ocean. So I don't
sure,
think we really know what we're going to disturb or find and what we won't. Right? It's we made that kind of analogy to exploring like deep space. Right? That
yeah,
the ocean is this vast sort of somewhat unexplored portion of the earth that we don't really know. But the reality of it is, at the end of the day, that we have to find other avenues to get these minerals that are becoming a very vital part of life. We can argue whether or not we need all this technology to the extent that we have it, but it's just a reality, right? And there's a global economic engine that's being driven by it, right? And it's so when you look at it, like that train has already left the station. So these are sort of, if you want to look at it, I mean, in some cases, maybe you could argue they're not critical, right? We're talking about, a phone that maybe you don't need. But then again, a lot of these, deep sea deposits contain things that are going to power like rechargeable batteries, clean energy systems, electric vehicles, all these things that, ultimately will benefit the planet, right? If we have more sustainable means of energy, then yeah, by all means, it's important for us to go and mine those minerals and push those technologies forward, for example, right? So I think
yeah,
it's like everything we talk about, Patrick, is always a bit of a yin and a yang. There's a good and the bad that comes with everything, and that's what we're always trying to decipher here, right?
yeah. Well, let's look at the yang here, because there's a lot of cons when you talk about environmental impact of systems we don't know. Okay, so let's talk about the positive side of this. Number one is the technologies that are going to be developed in order to perform these functions, right? Is incredible, right? It is, and that's going to benefit the industry, but it's also going to feed other systems. Because as you learn to develop new machines, new technologies, new materials, that knowledge tends to get moved over into other areas. It could be contribute to aerospace, right? Engineering, right? It could contribute to. I mean, we talk about Corningware as a great example of the polymetallics. The idea here is that you can't get anywhere by sitting still, right? And it takes a lot of money and a lot of time and a lot of engineering to make something like this happen. And yes, there's a big gamble here. Will you get those millions or billions back by doing this function, right? But let's say you do, right? That's going to drive more companies to try to do the same thing. So even if you have, say, a dozen companies, churning the abyssal plains up, how long will it take to, really make a dent in the ocean floor, from a biological perspective, right?
Well, there's a lot there, right? There's a whole, seabed that needs to be explored to understand the full scope of what's available, right? But you're right in the sense of, once these companies start to become successful, it's going to drive more and more of that, right? More and more impetus to do more exploration and to mine for more. If the riches are there, and to your point, that's kind of the whole thing in mining. Sometimes they don't know what they don't know, and I'm sure the technology is getting better every day for surveying and understand what might be there, right? But there was, a funny kind of anecdote there, and this was something related to sort of, it might have been in the book, like How to Think and Grow Rich, or something like that. Anyway, there was a book, a very classic book I was reading one time, and the idea was that your next biggest success could be like just within your grasp, but you give up before you get there.
Yeah.
Right. Yeah. So it's like, and the idea, the whole moral of the story is that you just keep going, because your next, as low as you feel, your next success might be right there. But they equated it to an actual, from what I understand, a real story of a mining company that on land that was somewhere, and they had been mining for whether it was 6-8 months, a year, trying to find gold, right? And this was many years ago, probably before we had a lot of the modern technology we have, but they had this idea that there was gold there. They had discovered some. They were digging. And finally, they just weren't getting there, and the finances of the company weren't looking good, and they just decided to give up, and they sold the whole operation, the rights to the land, to another company. And within months, this other company struck this like massive deposit of gold, essentially.
Okay.
And they became infinitely rich for that era of time. And anyway, it was just an interesting kind of like, I'm just equating it to what you were talking about, but it's kind of like a life kind of lesson, I guess, or what have you, that sometimes people give up before what might be their biggest discovery or their biggest opportunity for riches. And I just feel like the ocean is a little bit like that, because there's so much unknown, and all it's going to take is one company to kind of strike the right area, and next thing you know, they've got enough deposits to make 1 million iPhones or whatever, right?
Well, the idea is that we're trying to drive industry that supports us, right? Whatever that is. Hopefully it's sustainable, right? You and I have lots of conversations around what's truly sustainable, not building, washers and dryers that die in a year, or a car that you can drive for the warranty period, then it falls apart. That's not sustainability, right? That's just throwaway, that's a throwaway society. That's garbage. You're building a garbage hole, a big garbage pit. That is not sustainability, right? But if we look at sustainability from a point of view of being able to build new and better and longer functioning, machines and longer functioning technology that can help us, right? Help us survive, help us, create better uh, food, uh, maybe improve our transportation and impact the environment less, be able to, solve our energy problems, right? There's so much possibilities there. When we go down into these areas of unknown, we are discovering. And sure, we might find wrecks as well, you know,
Yeah.
of ships and submarines and what have you. Um, the idea is we just don't know what we're going to find. And we can find new species, we can find new types of, metals, new types of, high pressure environments like that. What can be created down there? Novel biology, right? Uh, and with that knowledge can filter up, right? And we can take advantage of that knowledge and maybe implement that in some other facet of our industries or in our learning anyway, of our base learning to enhance our understanding of how the earth really works. So to me, I feel like if we talked about the gold rush, right? The gold rush here, where you know a lot of these a lot of these areas were untouched, and then many people, many miners with hopeful thoughts rush in there and start opening up all these mines and
There's gold in them there hills.
yeah, golden hills. We build up, build up towns and infrastructure, and yeah, eventually, the mining died out, but the town stayed, right? Sometimes they didn't, but a lot of times they did, right? And the people forged ahead, and it was the miners that did it initially, right? That's what drove it. It wasn't all fur trading, right? So the same thing goes with our ability to go down into the very depths of the ocean floor. Us being able to build, sooner or later we're going to want to be able to get down there easily, right? For our engineers and our geophysicists, and all our scientists that want to get down and do the safety studies and the equipment maintenance and what have you. And so we're going to have to really improve on our ability to build, very robust, reliable equipment that can handle that type of extreme environment. So
That's pretty
that's
expensive, I would
yeah,
imagine, right? And do it in a reliable way, right? There was a thing here about specialized seabed collection vehicles can cost $10 to $20 million each. I
yeah,
mean, you need to start to have a pretty high return on investment when your vessels are costing like 10 to 20 million each, right? You need to really uncover a lot, or it's very risky from a financial point of view. And then you also, I mean, once you get or find those materials or those minerals or what have you, then you need to bring it to the surface somehow, right? So
yeah,
you got a whole other piece of technology that you're having to do to get it out of the ocean to begin
yeah,
with, right? But I mean,
yeah,
there must be a potential like financial upside, like we had talked about, right? There's those projections, but obviously those types of minerals are in high demand, so it's almost like a gamble in a sense, right? Like high risk, high reward in a sense, right?
yeah, yeah. That's right. High risk, high reward. And when we think about it, when you're developing, multi-million-dollar machines that are going to crawl along the ocean floor and harvest and or perform mining activities. I'm not just saying they're going to just harvest these nodules. They actually may actually do drilling and digging and whatnot. Um, you know, what happens if that piece of equipment fails, right? We're going to have to, are we going to make this equipment, be able to modify its buoyancy and actually float back up and get maintained? Or do we just leave it down there, right? And drop another one down beside it to continue on down the road, right? Um, that's a very expensive proposition to leave it, right? And so, when we're looking at technology like that, also, having it tethered by miles or kilometers of, wires and whatever communication we have there. What happens when that, component gets snapped, millions and millions of dollars no longer functioning, right? So we build these things with smarts, with AI, and these things now can, auto navigate up, right? And be found again. So there's lots of learning and engineering that needs to go into this effort in order to manage costs, in order to introduce, the ability of being effective down there, right? And actually
Well,
perform
not creating too much damage as well, right?
Yeah.
Like,
Yeah.
I mean, one of the things that, it can really wreak havoc in the environment is what they call these sediment plumes, right?
Yeah.
So that, we talked about on the, land, like, you have tailing ponds and other impacts, but really, I mean, these can spread for kilometers, right? Really, they can smother certain types of, fish and bottom feeders, right? Introducing toxins or heavy metals into the food webs that aren't naturally there, right? Disrupting feeding and reproduction of sea life. Just changing the water chemistry and carbon storage dynamics. Like there's so many things that can really wreak havoc there. So like we're getting these minerals and it's creating a lot of economic boom, but really causing a lot of havoc for these ecosystems and environments, right? And some of them have taken millions of years to develop, and we're destroying them overnight, and they're not going to grow back or reset overnight either, right?
Yeah. But at the same time, if you look at it from a point of view of, the cost of that small area to a surface cost, right? Where we're creating tailing ponds and such, the cost of humanity is a lot less, right? Mm-hmm. So I think we need to really balance this out. And I think that, personally, I think the benefits of attempting this are greater than the damage that you're going to create, right? Because nobody's living down there, because it's a no man's zone. It's a no. I mean, we're going to have life around, certain areas where we have plumes, right? We'll call it the magma and such, and heated water, just like any other volcanic area. That would be an active area that would be, possibly having different chemistry, and you have different forms of life that aren't relying on sunlight. So we avoid those areas, just like for the most part, it's like a desert, right? These plains are similar to that from a point of view of life, right? Now, that's how we understand it today. That doesn't mean that once we go down there, we learn more, right? We perform these functions. We may find certain areas that, we have to curtail our activities, right? Because, right? Now, that to me means that we have to work wisely and in conjunction with, the mining operations should work hand in hand with environmental, specialists and, the scientific community. And that is something that typically has not been a reality, right? It's, developers, for instance, just flatten the land and build wherever the hell they want, right? But we don't have to continue to do things that way, right? And we can point the mining equipment another direction if we find that, certain life is being is valuable, and we want to maintain that, that life, right?
No, for sure. But who really has, kind of say over this, or who's governing it? I mean, I guess as, collectively people of the earth, we have this sort of dominion over the ocean in a sense that we can kind of do whatever we want, right? But I think like who's kind of guiding that? When you look at, we've defined like land borders across countries or between countries, for example, right? But the sea is a whole different thing, right? And even you have this concept of like a landmass, owned by a country or owned by a government, and then there's a certain portion of that sea that they kind of control to an extent, and then you get beyond that, and then you're in what they call international waters, right? So like,
Yeah.
The international seabed mining is governed by the International Seabed Authority, which I didn't even know existed, the ISA.
Yeah, I see.
Which is still finalizing rules, right? But I mean, who controls the ISA? Like, who is the ISA, and who makes up the ISA, and who decide that they're the ones that get to like regulate the ocean, as it were?
Well, yeah. I mean, if we look at typically what happens, I mean, the UN's in a so-called authority too, but what's the how much teeth do they have from the point of view of being able to enforce what they set as a regulation, right? And that is a bit of a challenge too, because if you have an authority, but they don't have the ability to, or they're not interested in monitoring and or enforcing, then what effect will they really have, right? And that's why I say that to be respectful of a brand new area of research and discovery, we should try to do that in conjunction with other areas of knowledge. So it's not just the minor operation. It's also it's being done from a point of view of understanding, and if we do find resources and biology, that's great. But let's say the activity, the processes being used could down current affect upper level life, like whales or something. Somehow your activities are destroying kelp, and you destroy kelp, you affect whales, many other creatures that rely on that. Well, that kind of pollution, whatever is being created out there by the equipment that's doing the refining, that has to be managed, that has to be changed. So we need those feedback loops. We need the people involved, and in the actual activity, we need to have assessment of risks, live assessment of risks as they're occurring, to be managed, right? And that's our challenge, I would say. Nobody really knows what the true risks are. If you have a piece of equipment and it has, I don't know, it has a hydraulic system in it, and it springs a leak, and you've got 900 gallons of hydraulic fluid, floating across the ocean, what does it really mean? How is it really going to affect anything? Well, that's one, that's a critical failure of the machine. But if you have, through the mining process, you've got some kind of, you're setting certain, types of minerals or poisons or acids or something free by disturbing the ocean floor, or even, releasing carbon, what have you, in small amounts, but it's not really a failure. It's part of the process. That's the more dangerous one.
Yeah, absolutely. Yeah.
Right? Yeah. So that's why we need to have, not just one party, but a group of people, a group of interests involved with this. And
this ISA was started as part of the United Nations Convention on the Law of the Sea, something from pirate times. But it was sort of an agreement reached, right, through a collective kind of interesting, really, that enough of these, sort of countries have come together. 172 members, including 171 member states and the European Union involved. The ISA and its resources cover 54% of the total area of the world's oceans. That's a pretty significant number. It's still not all of it, though, right? So, like, who controls the other 50% or 46%? I guess that's sort of like pirate seas. Anybody that can kind of get at it can go down there and mine, I guess, right?
Yeah. Well, not anybody, because we're talking about so much money to get into the business, right?
Well, that too, yeah. I guess we're not getting into it anytime soon,
No.
but
Yeah. And I think that's the reality here, is that this is such a high priced and high cost. There's only so many entry players here we're dealing with. And that's why I think it can be managed, right? At the same time, if countries want to perform these functions on their, continental seabed, within their own, 200-mile jurisdiction, they can.
no, absolutely, yeah. But like you said, there's a lot of technology involved, so maybe we should kind of get into some of that, advanced technology, which is obviously, as we mentioned earlier, some of it really not cheap. But of course, we all know that AI and autonomous sort of vehicles and humanoids are going to solve all the problems of the world, right? So surely they're gonna lead the way when it comes to sort of enabling technologies for deep sea mining, right?
Yeah. I mean, we're looking at, very well. We're going to have to improve our ability to, image things in the undersea, right? And that's multispectral or hyperspectral type of imaging. We're going to need to expand that. So, when we're able to, we're looking for very small, components, like 2 or 3, 6 inches, and on a seabed. So, our imaging has to be, technology has to improve in areas where we've got this, very dark area, lack of light, very low temperatures, and very high pressure, and yet we're able to navigate that equipment down there effectively, and start farming for these nodules. So, yeah, that's one component that will have to be enhanced in what we're dealing with now. With that, of course, we're also dealing with the fact that this equipment can raise the turbidity, or it can raise up the ocean floor sediments and that kind of thing. So how is the imaging going to work to deal with that? That's a serious problem, right? When you look at existing equipment, so solving those problems is a incredible feat, right? And doing it in real time, right?
No, so there's definitely an aspect to sort of technology and surveying, the ocean floor and that type of thing. But there's also, advanced underwater robotics. There's the more remotely operated vehicles, right? Obviously they're being controlled, by an operator. But certainly if something goes wrong, then you don't have sort of a human in the loop underground to have to deal with that sort of high pressure or low light condition type thing. But then of course you have the autonomous vehicles, which we all knew were going to, get involved in some way in this, right? Where we have autonomous vehicles happening, all over the earth, right? And of course they're really without any sort of tether, right? They're just sort of let loose to go and explore and survey in like an automated way, right? Which is, I think, an interesting kind of aspect to it, that you could just set something autonomous loose and it can just go and figure out what's happening in this very complex, underwater terrain. But I mean, at the end of the day, it's like, again, these are very expensive technologies, right? But all of these technologies we're creating for use on the surface are going to be used underwater as well, especially when there's $20 trillion of opportunity down there, right?
Yeah.
And
Yeah.
I mean, as much as it is advanced technology and it is expensive, it is getting cheaper by the day, right? Once we get to the point where, you know, um, companies that like is running or what have you, I mean, they're looking at mass producing robotics, right? So it's only a matter of time before they mass produce them for like the seafloor, as it were, right?
Hmm. Yeah. I mean, the idea that once an industry gets started, right, then in order to become more effective at that, being able to build equipment at scale, right, at volume to perform the functions. And these are all usually they're not the same companies, right? You got different contracting companies. An amalgamation really of multiple companies that are involved with such an expedition, right? And all these different companies get involved, all these different contractors, and then this is where you get the learning, right? So one particular contractor builds out these components, builds the machines, the drones, the AOVs, right? Actually, the mining machine, and another one would build the equipment to actually perform the mining or be able to pick these nodules off the seafloor, or perform the drilling or what have you. And then so you have the different equipment that these vehicles would use. And of course, you got all the software and everything that drives these vehicles. And then you have lo and behold, we really haven't talked about this, but it's fine that you can pick it up off the seafloor or drill through a mountain and pull some cobalt out of a mount. And what do you do with it then, right? It's not always pumping mud, right?
Yeah.
So how do you get this, miles up to the ship, right? Through, what process you can use, balloons, right? And a lot of conversations where, have been performed around, it's just like a big vacuum pump, and we'll just draw up, multiple, kilograms of mining product, just pull it right up, right? Miles. So, what's the technology that's going to be used to draw all that up and, eventually get it into, the barge, or the refining ship, right? And,
well, that's really the key, right? How
yeah.
do you transport once you get it up? It's interesting that I was looking at this company, which I think has one of the coolest names I've seen yet, called Impossible Metals. I don't know where they came up with that name, but if you go to their website, they've got a whole one of those huge video banners, right?
Yeah.
That kind of shows was sort of their robot. I'm sure it's like an animation or what have you, going across the seafloor, and all these arms going down and picking up the nodules and dropping them to like
a little spider.
Yeah, like a conveyor belt type thing.
Yeah.
But what's interesting is we selectively collect critical metals while preserving and protecting the ocean as their tagline, right? And then they've got a link to their environmental approach, and they seem to be very, all their marketing is around this sort of like sustainable approach to it, right? Is it really, or is it just marketing? I don't know, but it's interesting that this is a company that's really, leaning into this idea that we're doing this, but we're doing it in a very responsible way, right? It says responsible seabed collection will drive a truly fair transition to circularity, they say, right? So interesting. I mean, I'm sure there's companies that are trying to do it that aren't, but then there's a company like this that's sort of leaning into the idea. Then they had their CEO testify before the House Natural Resources Subcommittee on, regulatory barriers to deep sea mining, right? And so there's always these companies that are trying to figure out, okay, what are the regulatory barriers? How are we getting, either past this? And they might be using this as a way of positioning their solution as being very, responsible in terms of the environment and so on, which very well might be true. I haven't done a ton of research into this, company, but at least it's good to see that a company is thinking about that, right? The impossible metals difference. It is, I, I can't love their company name anymore. Being a heavy metal fan since I was a kid, but I just love the company name. Impossible Metals. It's almost as good as what was the company that was uh, bringing the prehistoric animals back to life?
Yeah.
Colossal. That was it.
Colossal, yeah. Yeah.
That's the name of their company. It's Colossal.
Colossal.
I don't know. I think that's my goal. If I was to ever create a company, it's not about what the company does or what it's about or how much money it makes. It's all just about having the coolest company name on the planet. I don't know. It's a toss up now between Colossal and Impossible Metal.
And when we get into this advanced technology side of things, um, this will not stay just down, miles underneath the ocean. That's the whole point, right? These companies will find new and better ways of doing things, and that could benefit the military. That could benefit medicine. That could benefit, materials for engineering and so on. It's just that's the hard part too. That's the discovery component. That's the unknown, right? And we think about the risks, right? Or what are the risks, right? Are we going to trigger earthquakes? Are we going to, go drill down too deep and, create a volcano or something like that? No, right? Are we going to displace human beings? No, nobody's down there, right? Could we create an ecosystem issue, right? Could we create a low level ecosystem and it'd be like a dominoes and it affects us up, our food system, the higher ocean levels? It's possible, right? Could we affect climate? Unlikely, right? Not percentage. There's not a high percentage of known here, so
No,
not
fair
really.
enough. Yeah.
Could we have a lot of runaway companies just going like crazy here and mining like crazy and no oversight? Yes, that would be a risk, right? So to me, that's part of the process. Is if you want a license to perform these functions, then you need to have a process in place, right? And you need to have certain parties in place, and that's controlling the risk. That's managing the risk, right?
No, fair enough. But I mean, even the medium probability of the ecosystem collapse sounds pretty dire to me, right? So it's, the catastrophic risk here is irreversible biodiversity loss,
Yeah.
not sudden system failure necessarily, but some of these things are definitely plausible. But of course, you always have to research all of the plausibilities when you're embarking on these things, right? I don't think that's necessarily gonna stop anybody, but there definitely is a lot that could go horrifically wrong, but that goes for everything, right? That we've kind of looked at from the beginning of this podcast up until now, obviously including AI, right? You can't sort of get away from that, but like you said, it's about managing the risk, which is really important as well.
Yeah, I think AI is more dangerous than what we're talking about here, right? I mean, really. I mean, let's put the risk down to reality here. So, I mean, there's many different possibilities that we go down there, and we actually find there's a connection, 6,000 meters down to, 200 meters up, right? To a certain life form, right? It's possible, right? Is it probable? It's not probable, but it's possible, right? And this is where our learning, once we understand these, we don't understand how the ocean works, right? We understand currents. We don't. I mean, we think we understand everything, but once you start doing things down there, then you really understand, right? Yeah, and the other advantage I see too is this equipment. It's going to be running as as AOVs and kind of independently. They got a power issue that they got to solve too, right? So when we start looking at the technology to power these devices and over a longer term, so you can't be bringing this equipment up and sticking new batteries in it, and then if you tether it, the idea of tethering can work, but that's an added cost, and it's a process that could have problems, right? And you may not successfully tether. If you have a tether out to a device all the time, that may be a problem too. You get caught up and damaged, and your $1 million machine's broken. So there's many different engineering problems with this, and I would say that the companies are willing to step forward and say, I'm willing to do this. I say, well, okay, let's give this a shot, right?
Well, it's got to be worth it at the end, right? I mean, there's this $1 trillion industry being built around this, so there's obviously a lot of merit and a lot of the riches that can be had, and a lot of the benefit to humanity. But it's at the end of the day, it's there's a lot of validity and as we talked about in this trilogy, right? Deep ocean exploration and habitats, and now we get into mining, right? But it's all about like we talked about, the risk versus reward, right? In other words, an ounce of gold is worth what it is because of the human labor that went into finding and the getting of it, Patrick.
Thank you for listening to the Probability Podcast. Please join us next time for more musings from the generator and the discriminator.